In this video, I'm going to review with you how do we write the equations of parabolas in different type of forms, given them information we can see in a graph, and then how can we examine it, like by finding the average rate of change over a specific interval. You learned this last Thursday and Friday, and we reviewed it again this Tuesday, and now we're going to be tested on it tomorrow. So this is just a review, taking everything in. So given this first equation, we want to write the equation of the parabola in intercept form. So in intercept form, I'm going to grab another piece of scratch paper here. Notice that I can see two x-intercepts visually on this graph, and I can see another random point. So I have x-intercepts at -6, 0, and at -2, 0. Those are my x-intercepts. X-intercepts, and I have a random point, specific point, exact, not rounded, so random point of -3, 9. And it asks for us to write the equation of this particular parabola in intercept form. So what is intercept form? Intercept form is also known as factored form. And so I'm going to start by taking the two x-intercepts and plugging them in where I see a question mark. Also keep in mind that when I plug them in, it's going to lie to you on the inside. So instead of writing x minus 6, it'll be plus 6, and x plus 2 likewise. Now I'm going to come back to this part of the equation later. I need to now solve for a. And to solve for a, I'm going to cross this out so I don't make a mistake. I'm going to use that other random point. The other random point is going to allow me to solve for a. Well, how do I do that? This is an x, this is a y. I plug them in as is. This is the x, this is the y. And I only plug them in order to be able to solve for this variable a. Now a is the only variable here. So I get 3 and -1, and I multiply to get -3, and then divide. And what do I do with this answer? Well, once I know what a is, I come back to that first step, and I substitute, in this case, -3 in for a. So I drop this extra point. I don't go to this point, and sometimes a mistake is students write this line with an a in. No, I go to an equation. Our equation is y equals, now the a is -3, x plus 6, and x plus 2. What does this information tell me about this graph? It tells me the x-intercepts occur at -6 and -2, which I can see. It tells me that this parabola is going to open downwards. This is true. And it tells me because this number is greater than 1 that we have a vertical stretch, which means it's skinnier than the parent function. I can see that as well. The second task is, can we take this in intercept form and can we rewrite it in standard form? So there'll be equivalent equations, just in different forms that both represent this particular parabola. And we can do that. So again, this is intercept form, sometimes called factor form, and now we're going to go to standard form. To do that, I'm going to do some basic math here. I'm going to start by foiling the inside, and then I'll distribute the -3 afterwards. So foiling the inside, I have front, x squared, outside, 2x, inside, 6x, and finally 6 times 2 is 12. When I combine like terms, it'll be to my two middles. I get x squared plus 8x plus 12, and now don't forget to take that -3 and to distribute it. Y equals, we're writing an equation of this parabola. Y equals -3x squared minus 12x minus 36. So this is an equivalent form. This is standard form, this is intercept form. If you had a graphing calculator, if you went to Desmos and you plugged in this equation, and you went back and plugged in this equation, you would see they're the exact same parabola. The third part of this problem asks you to identify the average rate of change over the interval -3 to -1. A lot of times students, they're familiar with the words average rate of change and the word interval, but really what does this mean? Remember, interval is always in terms of x values. It's always in terms of x values. So this really means -3 and this means -1. Now, I'm a visual learner. If you're the same, I'm going to estimate where I see here on the screen, where I see -1. -1 is way down here, it appears. And I'm just going to highlight that. So that means that this part of the graph, looking at it from left to right, what's happening, it's going down, and then it's going down really fast. So the average rate of change is like the slope on a particular interval here, okay? So I know it's going to be negative, and I know it's going to be a large number because it's going down very fast. Now, how do I actually calculate this? Well, I go back to the equations I have. You can use either equation. It makes no difference. I'm going to write down the first one. And you can use the decimals calculator if you'd like. And I'm going to plug in -3 wherever I see an x, and I'm going to do the math. And in doing so, I'm substituting in the x, and I'm going to get an output for y. That's going to tell you what goes here. So 6 plus -3 is 3, and -3 and 2 is -1. And when I multiply, I end up with a +9. Now, I was also able to see that from the graph, but I'm just illustrating how do we do that if we can't see the exact number on the graph. I'm going to do the same thing with -1. -1 plus 6, -1 plus 2. Again, why am I substituting for x? Because it is the x value. Intervals are describing x's from -3 to -1. What is happening? So I have 5 and 1. And the output, when I substitute an input of -1 for x, I get an output of -15. What do I do with these two ordered pairs? There's x1, y1, x2, and y2. Okay, well, we're finding the average rate of change, like the slope, y2 minus y1 over x2 minus x1. So y2 is -15, y1 is 9, x2 is -1, x1 is -3. I choose to put parentheses so I don't make any small mistakes. -15 subtract 9 is -24, and two negatives make a positive here. -1 and +3 is 2. What does this mean? This means over the interval from -3 to -1, on average, for every unit I move to the right, it is going to decrease 12 units. So it's not going to be exact, it's on average. So here's down 12 over 1, down 12 over 1. Okay, here's a new problem and a new problem. So for this problem, we're asked to write it in vertex form. If you remember, vertex form looks like this: y equals a, x minus something quantity squared plus something. I'm going to replace these question marks on the inside where it's going to lie, on the outside it tells the truth. So it actually identifies, in this particular problem, it identifies what the vertex is. It identifies what the vertex is. So I'm going to type into this, 1 will be -1 because it lies, and then it tells the truth on the outside. Now, all that's missing is the a value. Well, how do I determine the a? I take the other random point, -1, 3, and I plug it in just as is. So -1 is your x, +3 is your y, and I now solve for a. -1 and -1 is -2. Don't forget to put the square. -2 squared is 4. Okay, now when I solve for a, I'm doing PEMDAS backwards. I'm going to start by adding 5 to both sides, then dividing by 4, and I have 2 equals a. 2 equals a. What do I do with that? I go back up to this step, and I write y equals, okay, my a is 2, a, which is 2, and then x minus 1 quantity squared, subtract 5. This is in vertex form. If I said factored form, I meant vertex form. I took the vertex and one random point, and I was able to create the equation of this parabola. The second task is to calculate the average rate of change over the interval from 1 to 4. Again, if you're visual like me, what does that mean? So I go to where x is 1, And in this case, I can see exactly what it is. It allows me not to do extra work. And now I need to find out what is the value of y that corresponds with x equaling 4. Now, here we go. Here's where x is 1, x is 4 is here. You can't estimate. We need to know exact. Well, from left to right, I can see it's going up, so I know my final answer should be positive when I make a prediction. Now, how do I get this? Well, x is 4, so I go to this equation, and I type in 4. I plug in 4. So y equals 2. I input in 4, and let's see what the output is. Input in 4, let's see what the output is. 4 minus 1 is 3. 3 squared is 9. 2 times 9 is 18, and 18 minus 3 is 13. So when I input 4, I get an output of 13. What do I do with this information to figure out the average rate of change on this interval? x1, y1, x2, y2. I choose to put parentheses just to make to lessen the chance of making a simple mistake. y2 is 13, y1 is negative 5, x2 is 4, x1 is 1. Two negatives make a positive, so this is really 13 plus 5 over 4 minus 1. 13 plus 5 is 18, 4 minus 1 is 3, and I know that 18 divided by 3 is 6. What does that really mean? Where over this specific interval, the average for every unit you move to the right, you're going to move 6 up on average. So if I go over 1 on average, it's not going to be exact, on average I should move up 6. Move over 1, and then I should be able to move up 6. Move over 1 and move up 6. That is on average. It's not going to be on exact. And final parabola from this lesson, we're given not the roots. We don't know the exact roots. I do see a y-intercept, and I don't see the exact. I could estimate, but we don't want to estimate. We want precision with our answers. All I see is 3 random points from this parabola, and I'm asked to write an equation of this parabola in standard form. How do we do that? Okay. So standard form, remember, let's start with this one. I'm going to take the x, and I'm going to square it. So negative 4 squared is 16. Then I'm going to write the x down as is. The c will always have a 1, and the output answer, which is negative 8. Taking this next one, negative 1 squared, write down the x as is, a 1 for the c, and the output as I see it. 0 squared is 0, write it as is, 1 for the c, and the output. What do I do with this information? So I'm going to switch. You should be able to continue to see the screen, but I'm going to switch right now and go to Desmos, and I'm going to have to type in up here Desmos matrix REF. I'm not sure if you're able to see this, but I'm going to plug it in. Remember that this is a 3 by 4 in terms of the dimensions or the size. How do we get that? Because there are 3 distinct equations and 4 distinct columns. So I'm just plugging in what I have. Again, I'm unsure in this view if you can see what I have, what I'm plugging into the R or EF, but I know that you've practiced this. And then I take the RREF of that particular matrix, and I get 2, 12, 8. Well, what does 2, 12, 8 mean? 2, 12, 8. So at the very end, it looked like this, 2, 12, 8. What does that mean? This is in your A, your B, and your C. A, B, and C. How do I know if they're positive or negative? If these numbers are positive, it's a positive in front. If this would be negative, it'd be a subtraction in front. I just wrote, and yeah, you could factor out a 2, but I put in standard form, this models this quadratic equation or the shape of this parabola. Now let's practice one more time. Let's do the average rate of change this time, and we're going to do it over the interval from -3 to 0. Average rate of change over the interval. Remember, these are x values as intervals. So here's 3, and here is 0. So let's make a prediction. I can see it's going up from left to right as I read it, and it's going up pretty fast. It's going to be a larger positive number. Why positive? Because it is going up. Now I can see that, oh, I don't see what the -3 goes with, but I can see exactly that 0 goes with 8. So how do I figure out what 3 corresponds to? This is your input, it's your x. This is your output, it's your y. So I'm going to plug in -3 for x, because it's your input, and I'll get an output value here in just a second. I'm going to come up above and do that. When I input -3 for x, I get an output of -10. Okay, now to find the average rate of change over this specific interval, remember both x's, x1, y1, x2, y2. My preference is to make parentheses y2 minus y1 over x2 minus x1. So 8 subtract a -10, 0 subtract a -3. 2 negatives make a positive. 2 negatives make a positive. 18 over 3 is 6. That means that on average rate of change, on average, every time I move to the right one, I'm going to go up 6. Go right 1, up 6, 1, 2, 3, 4, 5, 6. Right 1, up 6, 1, 2, 3, 4, 5, 6. Right 1, up 6. It's not going to be exact because it's the average of this particular line. It's not linear, so it's not going to be exact. So my answer again would be positive 6.